This is question 2, exercise 10F, page 100, and well, this question's on page 176, and this is a really good example of putting together all the things that we know about pulleys and forces and Suvat equations and all sorts of things and making a nice hideous question out of it. So here we go. I'm going to assume that you've read the question. So we're starting off with this situation here, which is that P and Q start at the same height, and it turns out to be quite important that they're starting off at the same height. There's a tension in the string which is keeping P and Q from accelerating downwards and just falling down to the ground. P has got a mass of km kilograms, so the force is kmg newtons pulling down. There's T newtons there, and there are 3 mg newtons pulling down here. The acceleration is this direction because Q is heavier than P, and that acceleration is 1/3 g meters per second in that direction there, and 1/3 g meters per second in that direction there. So we can consider the motion of Q, we can consider the motion of P. Both of them are accelerating, so we're going to apply F equals ma, and so far that will be sort of pretty straightforward. So at Q, we're going to consider the vertical motion, we're going to apply F equals ma. So we're going to get 3 mg minus T, that's the forces, that's the net force pulling it downwards, equals mass, which is 3m, times acceleration, which is 1/3 gm. The 3's are going to cancel out, so that's going to give us that T equals 3 mg. Oh, sorry, I've copied down that m from the meters per second, haven't I? That's the acceleration is 1/3 g. I'm just going to put some brackets in there so I don't make that mistake again. So where are we? T equals 3m minus mg, so T equals 2mg, and that's going to be my equation number 1. At P, we've got F equals, the vertical motion, F equals ma, and that is going to be the tension is pulling this thing upwards, kmg is the force pulling it downwards, so that's my net force, or my resultant force on P, equals the mass, which is km, times the acceleration, which is 1/3 g. So that is going to give me the tension equals kmg plus 1/3 kmg. So the tension is 4/3 kmg. And that's going to be my equation number 2. Now we can see from this, the first part of the question actually asks us to find the tension in the string, and here's my answer, 2mg. The next thing it's asking us to find is the value of K, and from these two equations we should be able to see that if we just sub, and by the way, you wouldn't start 2 columns if you're setting this out yourself, you carry on straight down the page, but I'm just trying to fit it all on the screen. So substitute 2 into 1, we're going to get 4/3 kmg is the tension from equation 2, and that is going to be equal to 2mg from equation 1, so the m and the g cancel out on both sides, so 4/3 k equals 2, so k equals 6/4, which is 1.5, and k is, well, I suppose it's a mass, isn't it? So sort of a kilograms, but it doesn't really matter, we're not going to worry about the units for k because they don't worry about them in the question. So far so good, reasonably straightforward pulleys question. Now is where it starts to get interesting. Q goes downwards for 1.8 seconds and then hits the ground. Once it hits the ground, it's immediately brought to rest, and P then flies up into the air, doesn't hit the pulley. So how far does P get off the ground? So this is what we've got to try and imagine then. So we've got our pulley like this, we've got P and Q dangling down at the same height, and I've got the ground here. So Q goes down and smashes into the ground and then stops. And at the point where we stop, then we're going to look something like this. Here is my pulley. Let's say it sort of looks like this. So here's Q down on the ground, and here's P. Now they started at the same height, and it's taken Q 1.8, I think it is, 1.8 seconds to make that journey, and it's taken P 1.8 seconds to make this journey. So the time that's taken for both those journeys is 1.8 seconds, and during that time they've been accelerating in the same sort of way. So they both started at rest at this initial height, and Q's gone downwards and P's gone upwards. They started at rest, they're accelerating in the same sort of way. So when Q hits the ground, the speed at which Q hits the ground is the same as the speed at which P is travelling upwards. Notice I don't say velocity because Q's travelling downwards, P's travelling upwards. So they've got different velocities, but they've got the same speeds because they've been using the same acceleration. So at that point, what we're going to have to work out, well, if we can work out the speed with which P is travelling at this point, that's the same as the speed with which Q is travelling after 1.8 seconds. And if we can work out the distance that P and Q have both gone in that first 1.8 seconds, then we've worked out this distance here, or this displacement of Q, if you like. That'll be the same as the displacement of P in this direction. So if we know that, whatever that distance is, at the point when Q hits the ground, P is going to be 2 lots of that distance off the ground. 2 lots of that, well, let's call it a distance rather than a displacement, because Q is going downwards, P is going upwards. So if we start talking about displacement and which direction we're going in, things get complicated. But that is where P is going to be when Q hits the ground. So we start, that's why P is when Q hits the ground. And then what happens is that P will be travelling upwards with a certain velocity. And that velocity is going to be the same as the velocity with which Q hits the ground. Now when it does that, the string is now going to go slack because there's nothing pulling the string back this way because Q is on the ground. So what's going to happen is P is going to do this, it's going to go up and then turn back down. I nearly said it goes up and stops because it doesn't stop, but it reaches a velocity of 0 instantaneously. And we can't show it like that on the diagram because we can't tell where the upwards and where the downwards motion is. So it travels up, and then by convention we sort of show it as though it had travelled sideways and then show it coming down again. And then of course eventually P is going to go all the way down to the ground and stop on the ground there. But what we're interested in is this height here. So this total height is 1 lot of this displacement, 1 lot of this displacement, and then this bit as well. So how do we find this height? Well, we're going to need to know the velocity that P is travelling with at the start, and then we can apply our Suvat equations. So that's what we're going to have to do. We're going to have to do 3 Suvat equations. 1 to find out this distance, 1 to find out this velocity, and 1 to find out this distance here. Then we're going to add this distance to itself to get up to this height, and we're going to add on this distance as well to get our final answer. Now, if you understand all that, and if that's where you were stuck, this is the point where you should stop the video and try all that yourself. You've perhaps noticed in the corner of the screen, this is a complicated enough question that I've scribbled down the notes myself. I'll go through them now, but I've had to scribble all this down to work it out before I started the video because the question is difficult enough that was necessary. So on the first stage of the journey, I'm just going to do the equations without the diagrams, which is perhaps not, well, you know what, let's do the diagrams. It's not good practice, so let's do the diagrams. So Q starts here and it ends up hitting the ground. So it goes that distance there, which we're trying to find, that displacement. I'm going to take the positive direction as downwards. So the displacement is s. The time taken is 1.8 seconds. The acceleration is g over 3 meters per second, and the initial velocity is 0, and the final velocity v we're interested in, and s we're interested in as well. So we've got u, v, a, s, t. U is 0, A is G over 3, S we're interested in, V we're interested in, T is 1.8. So if I'm trying to find, well, we need to find S and V, so it doesn't really matter which one we do first. I'll go for S first, and we're going to get S equals UT plus 1/2 AT squared. And when we're trying to find V, we're going to use the equation A equals V minus U over T. Now notice here, look, I could find S from this one, and once I've found S, I could use an equation that involves S to find V. But it's better technique to use this equation to find S and then this equation to find V, because this equation doesn't feature S. So if I made a mistake finding S, at least I'm going to get V accurately, and that makes it easier for the examiner to give me some marks, because I've got an accurate V. Let's not worry about going through all the details of this bit. I'll stick it on the screen quickly. Here's my rough working out, if you want to pause the screen and have a look at it there, but S ends up as 0.54 G meters. And for this bit, again, I'm not going to worry about all the working out, but, well, actually there's not much working out here, so let's see. We've got the acceleration, which is 1/3 G, equals V, which is what we're trying to find, minus U, which is 0, over T, which is 1.8. So if I just times by 1.8, and I can obviously ignore that 0, so it's 1.8 over 3 times G, and 1.8 divided by 3 is 0.6. So V is 0.6 G, and that is meters per second. So once I know those two, let's see what I found. I found that this distance here is 0.54 G. That's how far that is that's 0.54 G meters. This distance here is 0.54 G meters. And this velocity with which Q hits the ground is 0.6 G meters per second. So that means that this velocity with which P is travelling upwards at this point is 0.6 G meters per second. By the way, this diagram is not the sort of thing that you want to put as part of your final answer in the exam, but it might be helpful for your own sort of thinking to scribble this down. You might want to then sort of put it in a box and label it rough working or something like that. So this total height here is 0.54 G plus 0.54 G, which makes it 1.08 times G. That's that height. And then I'm just dealing with this this bit here. So let's have a look. So motion of P. Vertically, of course. So we've got so motion of P vertically, which and this is after Q hits the ground. What have we got? We've got U, V, A, S, and T. Here's P. It starts off, it's doing this sort of thing. Starts off with a velocity of 0.6 G meters per second. It ends up with a velocity of 0. I'm going to put the positive direction as upwards. Acceleration is minus G, in fact. I'll leave it as G because I'm leaving G's elsewhere in the working out in the hope that they'll cancel out, which I haven't actually mentioned. So if you're wondering why I'm leaving G's everywhere, it's because it's easier than dealing with 9.8s and dealing with lots of decimals. So hopefully my G's will somewhere cancel, and that'll save me a bit of bother. So U equals 0.6 G meters per second. So let's see what we've got. We've got 0.6 G meters per second. We've got V is 0, acceleration is minus G. Displacement I haven't put on the diagram, have I? There we go. Displacement is 0.54 G meters. No, it's not. Sorry. Displacement is what we're trying to find, isn't it? Displacement is what we're trying to find. 0.54 G meters. That was how far it's travelled so far. So S is what we're trying to find. And the time taken doesn't seem to be important. We're not interested in that. So looking at this, I'm going to have to use V squared equals U squared plus 2AS. 0 equals U squared 0.6 G all squared. Plus 2 times A, so that's minus 2G times S, which is what we're trying to find. So that's going to give me S equals 0.6 G squared, 0.6 G all squared, divided by 2G. So S equals, well, 0.6 squared is 0.36, G times G is G squared, divided by 2G. That G squared cancels out, so it's worth me keeping those G's in, made life a little bit easier. So S equals 0.18 G. So, what have we found? Go back to our initial thinking. That we've just found there is that S equals 0.18 G meters. So what we've got overall is this height, and this height is the final height that P reaches. So final answer, final height of P equals 1.08 G plus 0.18 G, which gives us 1.26 G. And if we convert that, if we get rid of the G, we get 12.3 meters to 3 significant figures. Now I think in the back of the book they've actually left the answer as 1.26 G, but obviously we can turn it into meters without the G very easily. So, quite a question, lots of things there, but if you're feeling like that's difficult and horrible and messy, just look at question 1 again. It's very similar to question 1. Look at question 3. It's very similar to question 3. So these questions are difficult, but once you can do them, you get a lot of questions that are very, very similar. So look out for that sort of thing.